Hello my dear students, welcome to the class of 11th English medium. The subject is statistics, chapter 3, measures of central tendency, brought to you by Vitan sir. Last time we completed the topics of combined mean and weighted mean with the exercise 3.2. This time I'm going to start with a new topic, that is geometric mean. That means we are still in the concept of means. We have completed arithmetic mean, combined mean, weighted mean, and now we are moving on towards the geometric mean. Now when value of a variable changes over a time, that means it changes in a year or a month or a day, and we are supposed to calculate the average rate of change, which might be usually in the percentages. We cannot calculate it using the arithmetic mean effectively. That means the changes and the rates of changes and its averages cannot be calculated using our regular mean. This thing I think we have already discussed beforehand in its disadvantages. So in the situation where we are supposed to calculate the average rate of changes, we use another measure, that is a special kind of a mean named geometric mean. Now what is geometric mean? Its definition could be: geometric mean is nth root of the product of n positive observations, and it is denoted by g. So arithmetic mean is summation and division, while geometric mean is multiplication and the root. Its formula, if I write down for n observations which are x1, x2 up to xn, it could be written as g nth root under root x1 into x2 into dot 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 into xn. That means in this formula we multiply all the observations and we find the root of those observations by the number n. So for example, if I am calculating for 2 observations, I will find square root of the multiplication of 2 observations. If I am calculating mean for 3 observations, I will find the cube root for the multiplication of 3 observations. Similarly, if I am having 8 different observations, I will find the 8th root of the multiplication of the 8 observations. So that is the geometric mean. Let's check out its advantages and disadvantages. Starting with the advantages first. It is rigidly defined, as you guys might recall that in the very early video I have explained the characteristics of an ideal mean or the ideal average. So first characteristic was it should be rigidly defined. So geometric mean is very simply and rigidly defined. We cannot interpret it any differently than what it was already given. Second advantage, it is based on all the observations. Just like arithmetic mean or combined mean or weighted mean, geometric mean also uses all the observations. Number 3, it is suitable for further algebraic calculations. That means using the geometric mean we can do further calculations. Then it is comparatively less affected by too large or too small values. The arithmetic mean is usually affected hugely by this gap, but geometric mean is not affected by too large or too small values. The next will be the disadvantages. The first disadvantage it has is that it can be found only if all values are positive. In the definition itself, it says that n positive observations. That means if even a single observation is negative, we cannot calculate geometric mean for the observations, as it includes the root method, and root is quite sensitive towards the negative values. That's why we cannot calculate geometric mean if any value is negative. Next disadvantage, that it is difficult to calculate. Of course it is difficult to calculate. Calculating a root is not an easy task. And then if the number of observations are say 15, how are you going to find the 15th root of the product of 15 different observations? So when values are big or the number of values are big, it is too tedious to calculate geometric mean. Here we are just multiplying these numbers, and naturally those numbers goes to millions and billions and trillions if we multiply them together. So it is actually a difficult measure, very effective measure, but a difficult measure with certain limitations. So it is used less than the use of arithmetic mean. Now there are certain things which you should note down first. The first thing is that if the given value increases by p percentages, it is written as 100 plus p percentage. That means when you are calculating geometric mean and you see that okay, price of a commodity increased by 10%. So you don't use 10% directly. You add that 10% into 100 because it increased by 10. So taking a base 100, you add other 10 into it and you will get 110. So you don't use 10%, you use 110 percentage as the calculating measure. So for example, your values increased by 10, 15 and 20%. You will not find average of 10, 15 and 20. Rather, you will find average of 110, 115 and 120. So that is the method of calculating geometric mean. I will explain it in the further illustrations afterwards, so don't worry. The second, that if the given value decreases by p percentages, it is written as 100 minus p percentages, same as the above. If your value is increasing, add it into 100. If your value is decreasing, deduct it from 100. I hope you guys have studied in accountancy that when we are calculating the depreciation, we reduce values by 5% or 10%. That's the depreciation on assets. For example, I want to find the average depreciation of 5 years. So naturally, I will calculate it at as 100 minus 5%, 100 minus 10%, 100 minus 15%, and then I will find the average of the remaining values. So just like with the plus, with the minus, we have to follow the same concept. And the last note which you must write down is that for the given observations x1, x2 and xn, the arithmetic mean will always be greater than or equal to geometric mean of the same observations. That means if the observations are same, the arithmetic mean and geometric mean were compared, then arithmetic mean will be either equal or more than geometric mean. Always, it will never be less than geometric mean. So it can be symbolically written as x bar is more than equal to g. But then again, if all the observations are same, that means the observations are 5, 5, 5, 5, 5, 5 or 10, 10, 10, 10, 10, 10, then x bar will be equal to geometric mean. That means when all the values are equal, x bar is equal to geometric mean, but in all the remaining cases, x bar is greater than geometric mean. Okay, so if observations are same, x bar will be equal to geometric mean, but if observations are not same, then x bar will be greater than geometric mean. Remember this thing and note it down in your notebooks properly. We will finally start with some illustrations to understand the concept. Illustration 14. The population of an area increased by 15%, 18%, 13% and 20% for the 4 years. Find the average rate of increase in population. Now basically no measure is given here to calculate, but remember, whenever this percentage increase or percentage decrease kind of questions are given, always do the geometric mean. I will name these observations. The first observation is 15%, so that will be 100 plus 15, 115. The second will be 100 plus 18, 118. Then 100 plus 13, 113, and last 100 plus 20, 120. So the observations which I am going to use for calculating geometric mean is 115, 118, 113 and 120. Now write down the formula for geometric mean here. G is nth root of x1 to xn observations. Now put down the observations here. That is 115 into 118 into 113 into 120 with fourth root, because 4 observations are there. Multiply the observations first. Now how to calculate fourth root? You know that on your calculators you have a button of square root. Okay, so when you press that button once, it makes the square root of the given data. So square root is basically 2. Okay, so 2 root can also be known as a square root. So when you press it twice, 2 twos are 4. That means when you press the square root button twice, it becomes the fourth root. Are you getting my point here? That 2 root when pressed twice becomes the fourth root. If you press it thrice, that is 3 times, it becomes 2 twos are 4 twos are 8th root. So basically using your calculators, you can also only calculate a geometric mean of square root, fourth root and eighth root. If you get a value in between them, you are on your own. Your calcs can't help you guys. So whether it's a square root, fourth root, eighth root, 16th root, 32nd root, 64th root, that is in the power of 2, you can calculate roots on your calcs. For the remaining number, you have to do it orally. But you are lucky enough, and actually textbooks people have only given you questions which are in the range of 2, 4 and 8 in your syllabus. At the most it will be cube roots, but cube roots are something which you must know yourselves. So right now you are supposed to do fourth root. So write down this value 184009200 on your calculus and press your square root button 2 times and you will get the answer 116.47. So the answer here is 116.47, but no, that is not actually your answer. You are only supposed to calculate the percentage increase. So how we are going to do that? The average rate of population growth is 16.47%, and how we got that? 116.47 minus 100. In the initial stage, we added 100 in all the observations. So at the end, we will deduct 100 from our final answer. So 16.47% is the average rate of population growth over 4 years. I hope you guys got this concept properly. I will be moving on to the next illustration. Illustration 15. This is a reverse, the opposite kind of a sum where we have to go back. The geometric mean of two numbers is 2. That means the GM is directly given. If one of the number is 4 times the other number, find the numbers. That means one of the numbers is 4 times the other number. That means one is a small number, other is a big number. The big number is 4 times the smaller number. What I'm going to do, I'm going to assume that the smaller number is x1 and that will be a. I am just assuming the smaller number is a. Now if smaller number is a, the bigger number is 4 times the smaller number, so it will be 4 times x1. I will name that number x2. That will be a 4 is the 4a. So the bigger number is 4 times a, that is 4a. What we are going to do, just put this value into our geometric mean formula. Now geometric mean is 2. There are two numbers, so 2 will be 2 root or the second root or the square root of a into 4a. The two numbers are a and 4a, their square root is there and the answer is 2, which is already given in the question. Multiply a with 4a and you will get 4a square. Now you need to find the square root of 4a square, so square root of 4 will be 2 and square root of a square will be a. So 2 is 2a. So when I divide 2 with 2, I get a is equal to 1. And if a is equal to 1, then 4a is equal to 4. Logic, right? Thus the numbers are 1 and 4. Got it guys properly? Okay, let's move on. Illustration 16. Find the arithmetic mean and geometric mean of two numbers 9 and 16 and verify that x bar is greater than g. Now of course these numbers are not same, that's why the x bar cannot be equal to g and therefore x bar must be greater than g, but we need to prove that. So how are we going to prove it? I will take x1 as 9 and x2 as 16 and the total number of observations are 2. First, let's recall how to calculate mean. That is x bar is summation xi upon n, that is 9 plus 16 upon 2, that is 25 upon 2. The answer is 12.5. Similarly, geometric mean will be the square root of 9 into 16, that is square root of 144, that is 12. Now because regular arithmetic mean is 12.5 and geometric mean is 12, naturally arithmetic mean is greater than geometric mean. That is what we were supposed to prove, and that's what we have proved. Okay, so those were the three illustrations which were given in the textbook for this topic, but I think these illustrations are not enough to explain the concept properly, so I am also going to solve the exercise uh, 3.3 in this itself. So exercise 3.3, this exercise is based on geometric mean only. We will start with the first sum. The following data shows the number of books read by 8 different students of a class during last month. That is 2, 1, 5, 9, 1, 3, 2, 4. Find the geometric mean of the books read. So we have 8 different observations which are to be found, the average of which are to be found using the geometric mean. Write down the formula for geometric mean. Now because there are 8 observations, we will be calculating 8th root of the multiplication of all the 8 observations. So write down its multiplication. The value here will be 2160. How to calculate 8th root? Press your square root button on calces 1, 2 and 3 times. That is 2 2s are 4 2s are 8th root. So 1, 2, 3 and your answer will be 2.67. So the geometric mean of the books read by 8 students during the last month is 2.67 books. The average number of books read by a student in the past month is 2.67 books. Actually this concept is very easy concept. The second question, and luckily there are very less number of questions in this exercise. The value of a machine depreciates at the rate of 10%, 7%, 5% and 2% in its first 4 years respectively. Find the average rate of depreciation. Now in the illustration we had the appreciation, that is increase. Here we have depreciation, that is decrease. So decrease means we will be deducting all these values from 100. So first observation will be 100 minus 10%, that is 90%. Similarly 100 minus 7, 93, 100 minus 5, 95 and 100 minus 2, 98. So the observations which we are going to use for the geometric mean is 90, 93, 95 and 98. Putting these observations into our equation here, that is g is equal to nth root x1 into x2 up to xn. Putting the values, fourth root 90 into 93 into 95 into 98 and its multiplication will be 77924700. That could be 77 lakhs 90 my mistake 7 crores 79 lakhs 24,700. The fourth root means press your square root buttons twice and your answer will be 93.95%. But once again, this is not actually the final answer. In the initial stages we deducted this value from 100. So right now again we will deduct this value from 100 to get our answer. Thus the average rate of depreciation is 6.05%, that is 100 minus 93.95% over 4 years. So 10, 7, 5 and 2% gives us the average 6.05% of average depreciation. Just like we deducted it in the initial stage, we have to again deduct it, the answer from the 100 to get our final answer, that is 6.05% every year. Yes, this will be the last question of the exercise 3.3. A taxi traveled 15 kilometers on Monday and 254 kilometers on Tuesday. Find the average distance traveled over these 2 days using geometric mean. A pretty simple sum to end the exercise and the tutorial. The first observation is 15 kilometers and the second observation is 254 kilometers. Write down the formula first and then put the values, that is 15 into 254, as there are only two observations. We just have to find the square root. Only pressing the button once should be enough. So first multiply 3810 and the square root will be 61.73 kilometers. Just write the statement here that the average distance traveled in 2 days is 61.73 kilometers. Thus the exercise 3.3 ends with that. Our concept of geometric mean is also over. I hope you guys got this concept properly. It's a pretty basic, pretty easy concept with a very straightforward formula. Actually there is nothing hi-fi like frequency distribution in your syllabus, but when frequency distributions are there, you don't need to do much. You just need to multiply your observations with the frequencies and then multiply those frequency observations with the other observations. So in arithmetic mean you add FIXI, in geometric mean you multiply FIXI with other FIXIs. In arithmetic mean you divide that addition with the number of observations, that is summation Fi. In geometric mean you find the summation Fi, that is nth root. So nothing different. In place of addition there is a multiplication and in place of division there is the root. If you know that transition well, you can do any kind of a sum, whether it's from the syllabus or out of the syllabus. I hope you guys got this properly. In case any doubts, you can just contact me. The number is given right now. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.